mathematicians, and welcome to your first lesson on percents. We're going to talk about what they are and how we can convert between a fraction, a decimal, and a percentage. All right, let's get started. Our first note in our notes is that a percent represents a fraction which has a denominator, a bottom number, of 100. The actual word percent, if we break it down, per, we remember from ratio unit, means for every one. Cent, think about how many cents are in a dollar, 100. How many years are in a century, 100. So the word percent literally means for every 100. So if I tell you we're talking about 25%, you can write me the fraction because that really means 25 out of 100. Percents, fractions, and decimals can all be used interchangeably. That means doesn't matter which one you use, they will still represent the same amount if they're equivalent. And in this lesson, we're going to be talking about how to convert or change between these different forms. So I will expect that if I tell you a percent, by the end of this lesson, you'll be able to tell me, oh, 25% is the same as 0 and 25 hundredths. Hundreds, percents are out of 100. You might be able to figure out how we get the decimal form. We'll also write fractions. They start out pretty easy, 25 out of 100, but then fractions, like you've known before, need to be simplified. So each fraction will have a different scale factor depending on what numbers you have. Here, I know I can divide them both by 25. I find it very helpful to think about money in this point. I think about 25, that's like quarters. There are 4 quarters in a dollar. This simplifies to 1/4. Throughout this lesson, I will also give you pictures. Throughout this unit, I'll also give you pictures of fractions, like these 10 by 10 grids, 10 across by 10 tall. That means there are 100 pieces, 100 little squares in here. Or I'll give you fraction strips that are not always out of 100, and I'll expect you to be able to write the fraction amount that's either shaded or not shaded, depending on what the question is asking. And then if this was saying how much is shaded, change it into a percentage. Now we're going to be talking about these skills later. Today for pictures, we'll mostly be focusing on the hundreds grid. There will be a lesson later that focuses on pictures and fractions that are not out of 100. Okay, let's start with our first skill. You will need to be able to do this by the end of this lesson. If I give you a decimal and I say, what percentage is this? You're going to need to be able to convert them. One way to do it is to think about the place value. This is 9/10, so I'm going to make them all out of hundreds place value. 90 hundredths sounds like 90 over 100. Another strategy when you maybe don't have just hundreds is to think about it this way. We're going to move our decimal point 2 places to the right of where it starts. So here, I've got my decimal point. I'm going to move it 1, 2 places, and this becomes 90%. 1, 2 places, this is 3%. 1, 2 places, this is 42, and we don't drop the decimal point, it just goes right here, and 0.4%. If I give you a decimal, you should be able to change it to a percentage. I might also give you a percent and say, no, actually I wanted a decimal. So you have to be able to do it backwards, in reverse. If we just moved our decimal point 2 places to the right to change it into a percent, then we're going to move it 2 places to the left to change it back to decimal form. If I give you 35%, we can remember that all whole numbers, like 35, have a secret hiding decimal behind them at the end. Or if it's not a whole number, like right here, the decimal point is already in the problem. But if you don't see one, you can put it at the end of your number and then move it 1, 2 places to the left. Now, I strongly recommend that you put in your leading 0 when you write a decimal point or a decimal problem, because I will give you some problems that are more than 100% and they will have whole numbers there. So it helps you to really recognize which ones are more than 100% and which ones are less. So keep your 0 there if you can. 72, remember the hiding decimal. 1, 2 places to the left. This is 0 and 72 hundredths. Another option is to write the fraction as you convert and then say, okay, I'd put this 35 with the 5 ending in the hundreds place. This would be 72 over 100, so the 2 would end in the hundreds place. This would be 3 100s, so the 3 will end in the hundreds place. Or if you're doing it this way, 1 2 places, and you fill that empty space with a 0. So this is really 0 and 3 hundreds, like this. If you write this, you are wrong, because that is really 0 and 30 hundreds. That would be 30%, not 3%. Last one, 1 2 places, 0 and 835 thousandths. And that's okay because we had like a part of a percent, a decimal amount. So you can have more than just 2 numbers in after your decimal point, so long as they are following the appropriate 2 moves to the left. Okay, fractions can be the hardest ones. It kind of depends on what the fraction is. Option 1 is it's super easy and it's already out of 100. That would be 4%. Option 2, it's not out of 100, but you can easily scale your way up. I know that 2 times 5 is 100. So I'm going to do 7 times 5. That's 35 hundredths. That's 35%. Option 3, they're not as easy. I don't know 12 times tables that will get me exactly to 100. But I do know that I can simplify 6/12. Divide them both by 6. This is equivalent to 1/2. I can get 1/2 times 50 50ths. That's 50 out of 100, or 50%. So sometimes you have to simplify before you can scale up. And sometimes it's just straight up not going to work to simplify or scale up to 100. That's okay. The final strategy is, if you cannot think of anything 6 times no whole number will equal 100, and you cannot simplify this unit fraction, then what you do is you divide. The numerator always goes in, the denominator always goes out. You can add a decimal point and some zeros, and all of a sudden you're saying 6 into 1. No, decimal point raises to the roof. 6 into 10, oh, that's 1 time. Minus, that's 4. Bring down your 0. 6 goes into 40. 6 times 7 is 42. 6 and 6 times, that's 36. Subtract, that's 4. You can always keep adding zeros. Oh, I'm starting to see, wait, we just had 40. Okay. At this point, you can probably stop and move your decimal point 1 2 places. If you kept going, the 6s would just never end. So this would be 16 and 6/10 that never ends percent. This one this type of problem we won't deal with as much, but when in doubt, it works even for other problems. If you're just not seeing the scale factor, you can always divide your numerator by your denominator to change a fraction to a percent. And those are the skills we'll be practicing in this lesson.